Hi everyone. It's just another happy Friday graduation. You could not be more welcome. I am not the person, and this is not the place to comment on the wider world at the moment, but I hope you'll take this opportunity to reflect on the value of some of the characteristics that all our students display, especially in this project phase, the fruits of which you are about to bear witness. The skills on display are impressive and the technology always intriguing, but it's the commitment to self-improvement combined with an honest collaborative spirit, the coming together to solve problems and overcome barriers, which brings us the most pride and joy, but also the most hope. 3 groups are graduating today, and I shan't interrupt the flow between them, but instead give my notices now. We're recording this graduation to avoid any technical hitches, but the presenting students are amongst you if you're watching this live, so your engagements, questions, and appreciation will be most welcome. And don't be a silly Billy, please do like and subscribe so you're aware when our next graduation hits the interweb. Please, once more, show your appreciation for today's teams and their projects. It's more exciting disruption to the taxi business with cabs. JJJS are bringing us a post-COVID solution for small businesses, and TapThatMap have a sleek new offering in that most beautifully nerdy of subgenre, the geography quiz. Strap in.
Good afternoon everyone, my name is Luke and along with the help of my team members Aniket, Daniel, Joanna and Niels, we're here to show you exactly what we've been working on for the last 3 weeks. Cabbed. Cabbed is a proof of concept Flutter application built for both iOS and Android, designed to level the playing field within the rapidly evolving taxi industry. The sharp rise in app-based ride-hailing businesses has forced the traditional black cab industry into a period of forced innovation if they are to survive. Because of this, we chose to design a real-time customer hotspot locator, taking advantage of the Google Maps heat layer to provide the user with continuous data on the intensity of customers at geographical points, all based on data returned from other users. This allows the user to consistently assess footfall around the city, allowing drivers to both target and avoid busy and quiet locations, fine-tuning their shifts in order to maximise cost efficiency and thereby enhance profit margins, all the while providing greater accessibility to the general public. I'm now going to pass you over to Niels, who's going to present you with a demonstration of exactly how Cab works.
Thank you, Luke. Without further ado, we'll jump into the presentation of our app. As you can see, we've come to the login screen of our app. Here we can choose to either log in with our social credentials or we can do it through the user sign-up form. For this demonstration, we choose the user sign-up form. We'll fill in the details of our new user and then at last we'll add a picture from our downloads folder. Normally we would use the camera function of our mobile phone, but for the purpose of this demonstration we're using an emulator, so that's not possible. We then click the Let's Work button, which makes a post request to our database and returns a message that the user has been successfully created. From there it will take us automatically back to the login page. Once we've finished the sign-up process, we return to the main screen to log in with our newly created user credentials. We tick the Remember Me button to signal to the app to remember us the next time we start it. After we log in, we come to the main screen of the app, generated with the Google Maps API. We see a lot of custom markers on the map. These are placed by our other users and we'll return to them shortly. For now, we are going to click the bottom left button on the screen and toggle our current footfall heat map. We make a decision based on the current hotspots within the city and decide to travel to the Manchester Library first. While we set off on our journey, we decide to have a look at the map. While traveling, we can see we are going to cross a few markers on our way. These markers indicate social events or other things the other users of the app want to make someone aware to. They are placed by pressing the top button on the screen, something we will do shortly after. By clicking on any of these markers, you will get a time of placement. These stay active for up to an hour, and then they disappear. As you can see from the demonstration, we decided to place a police incident marker on the road that we are traveling on. These will pop up directly and in real time for any other users. As we arrive to the Manchester Central Library, we pick up our first customer and click the pickup button. By clicking the pickup button, we send a post request to our database with the information of this pickup. We use this data to generate future hotspots based on the data submitted. As we will do now, we will toggle the current heat map off and we will click on the past heat map. The past indicates past hotspots based on the last 4 weeks of submitted data by our users, and it clearly signals that Manchester Piccadilly will be rather busy for the coming hour. It might be wise for us to travel there. For now, we decide to click on our user profile. From there we can see an overview of all the markers we've placed, the pickups we've placed, and our user score based on those totals. It also gives the user the ability to log out, which is what we'll do next. Logging out returns us to our home screen, and that concludes the presentation of our app. For now, I'll hand you over to my teammate Daniel, who will talk you through the front end.
We chose to build our front end using Dart and Flutter. We knew we wanted to build a native cross-platform app and saw React Native and Flutter as our two main choices. After some spiking in the first few days, we chose Flutter for a number of reasons. Flutter has a huge library of UI components which we could use to easily customize our app. We really like Flutter's DevTools suite for debugging, and this, along with the hot reload feature, would allow for speedy iterative development. We also found that Flutter and Dart had great clear documentation, as well as a wealth of online learning tools. We spent a lot of our time in the first week familiarizing ourselves with Dart, as this was a completely new language for all of us. Using local emulators, we were able to run a live version of our app on our machines for development and testing. For the map portion of CABD, we used the Google Maps Flutter plugin. The heat maps functionality for this plugin is brand new, so documentation was sparse and use cases were few. However, this was the only plugin we found with all the functionality we wanted. Although it was challenging, we were really happy with how we got things working as we had originally envisioned. Upon loading the map page, the map centers on your current location and HTTP GET requests are made to our backend to get relevant points from markers and pickups, which can then be displayed on the map. This data is refreshed automatically every 2 minutes with a fresh GET request. New pickups and markers are added with post requests when the relevant buttons are tapped. We also used Adobe XD to create views of our app, and Adobe Illustrator and Photoshop to create design elements. Throughout the project, we employed agile working practices. As we were using tech that was new to us, it was difficult in the beginning to predict all of the challenges we would face. Agile practice allowed us to react quickly to relieve bottlenecks. Using pair programming and mob programming to combine our skills and knowledge where challenges arose. Throughout the project, we kept up to date with twice daily stand-ups, where we reviewed and updated our Kanban board on Trello. This allowed us to remain focused on our MVP and let the design evolve iteratively. I'm now going to pass you on to Joanna to talk about our backend stack.
For the backend, we used an Express server and Mongoose to connect to a MongoDB database. After spiking some ideas for the database, we chose MongoDB because thinking long-term scalability was really important, as the database would need to store large amounts of data. MongoDB uses horizontal scaling to solve this problem, so we could increase the amount of data with zero downtime and using multiple servers. Another reason we chose MongoDB was querying the database was a lot easier than some other databases, as it is flexible and it avoids the concepts of joins. Naturally, after choosing MongoDB, we decided Mongoose was best fit for connecting to an Express server. The database has 3 schemas: users, which has all data for a user profile, pickups, and markers. The pickup schema has all previous pickups and made by all users, and likewise for the markers. When a user signs up, the data is posted into the user schema, and when they log in, it sends back the user's data. We wanted to make sure all passwords would be encrypted for user security, and to do this we used Argon2, a cryptographic hashing algorithm. For the pickups and markers, the user can see all the data posted from the past hour. When a user makes a post request, the data has the coordinates of the location, and we also included the user's ID, so when you go on their profile page, you can see how many markers and pickups they've made. The markers also have a type of event, which the user picks from the drop-down list. We also thought it was important not only to show data from the past hour, but data from the past hour for the past 4 weeks. And to do this, we had to separate the time and date. We used a package called Moments to format the timestamp in the schema and have time and date separate, so that we could easily filter through the data and send back what was needed. We tested the endpoints using Mocha, Chai and Supertest, and in order to test all the endpoints successfully, we had to have a large amount of data from the past 4 weeks, with different locations, different times, and different types and different users. To do this, we used random generator functions. For the coordinates, the function would take the radius and a center point, and for this example, we used St. Peter's Square. The function would then create random coordinates within that area. We did the same for all information needed for the database, and we then tested the data to ensure that what we were sending back was in the correct format and added it to the database to be used in the front end. I'll now pass on to Anakit, who will talk about the challenges we faced and what we would have liked to have done differently.
Thank you, Joanna. One of the major challenges we had was to emulate footfall data. We were looking at APIs that could provide real-time data, essentially providing data that tracks people, which was impossible. So for testing and demonstration, we had to emulate the data by creating a JavaScript function that gave us a number of coordinates within a mile radius of Manchester. Another problem we had was working remotely, and so far we are the only international team working in different time zones. This was of course challenging, but we managed to find a solution using various tools at our disposal, such as Zoom for cloud meetings and daily stand-ups twice a day, VS Code Live Share for pair programming, Git for version control, and making use of standard agile practices, making it quite easy. Overall, we had a great experience working together as a team, and although we were not very familiar with some of the tech that we used, we learned how to use them, and we are very proud to show all of you what we created. I'll pass you over to Luke now.
So, as I look forward to the future, there are a few things that we'd like to see happen. Firstly, as I said at the start, our application is reliant on the participation of multiple users. With no users, we have no data, and with no data, we have no product. Because of this, we'd like to see a real-time acceptance test across the city in order to truly determine whether or not this meets a business requirement. Second is scalability. As Joanna alluded to, we chose MongoDB for its scalability benefits. Our app is currently only designed around Manchester city centre. However, we would like to see it grow across other major cities across the country. So, on behalf of everyone at CABD, we would like to give a massive thank you to everyone who took the time out to watch our presentation. We hope you enjoyed it as much as we did, and we hope you enjoy the rest of your weekend. Thank you.
Welcome to Independent Leeds. We created the Independent Leeds app because we wanted to support local businesses, many of whom are facing bankruptcy due to COVID-19. We've been inspired by the way that local businesses have been adapting, for example, by transforming themselves from a restaurant into a takeaway, and by apps like Now Then in Sheffield and iTown in Wales. We wanted to build a progressive web app so that it would be accessible to as many people in Leeds as possible, including those with unreliable network connections, older mobile phones, or who would access it through desktop only. This app is for everybody in Leeds, but particularly for those who want to see their small local businesses thrive. I'm now going to hand over to Simon, who'll show us how the app works.
Thanks, Jodie. So now I'm going to take you through the basic user experience of Independent Leeds on a mobile phone. So upon reaching the site, the first thing you need to do is register to create an account to access the site. So that's simple as register, type in a username you'd like to use, an email address, so mine for, for this demonstration, and a password. Okay, hitting register then sends an email to the inbox, and in there, in that email, just click the verified link, and now you're an active user on the site. So back on the page, select login and put in that username, that password. Login takes you to the main page of Independent Leeds. Great. So from here we've got a map, we can see the businesses that are registered, and below that we can also see some cards relating to those businesses. Now this map, when you zoom in and reduce the number of businesses shown, the number of cards below that also reduces. So it's quite reactive and responsive to that. Of course, that's one way to navigate the site and find businesses, but if you're like Claire and you know exactly the type of food that you want to eat, well, you can use the drop down menu and the filters below. So selecting British from the list and then hitting filter will show the British cuisine businesses. Okay, well, Claire is also a vegan. Well, we've got you covered. Click on the vegan checkbox, filter again, and it reduces even further the number of businesses. So what about TapThatMap? Well, Claire's a Yorkshire lass, so she's going to try that. Clicking on the link takes you through to the information page. Scrolling down a little bit, you can see information about what type of business it is and whether you'd like to frequent it. Sounds like it's right up Claire's street, so she wants to book a table to have dinner there. Well, luckily that's something that's shown on the site. If the owner chooses to, they can show the number of tables currently available. Luckily there are tables left, so Claire's going to book a table. Scrolling down, you can find the phone number, a quick call, and that table's booked.
One wonderful meal later.
Okay, now she's had her meal, what can she do to share her experience with other users? Well, firstly, back on TapThatMap's page, she can support the business. So that will make Yorkshire Dave very happy. She can also leave a comment. What a wonderful place. Clicking show comments, you can see that hers is at the top. But there's a spelling mistake. No problem. Click delete comment and it's gone with a quick yes to confirm. And there we go. She can add another comment, but she can't delete anyone else's comments because that button only appears for her on her comments. Now at this point, Claire is really happy. She wants to register her own business, her cat cafe. Well, no problem. Click on the hamburger, select register business, and there's a nice form with all of the information that she can fill out about her business. But for the sake of brevity and through the magic of video, ta-da, it's all filled out for us. Okay, now at this point, registration needs to be verified. So if I just put on my admin hat for a second, log in as admin, I can then select verify from the nav bar and I can see her business. I can click verify and then the business will appear on the site. Claire can visit her own page and she's just looked at the information and realised, the phone number's wrong. Well, no problem. For her, there are little edit buttons to click on. She can select the one next to phone number, put in the new phone number, update, and there we go. Her users can get in contact with her and book tables at her restaurant. So, there we go. Claire's very happy. I hope you guys have found it interesting too. Over to Joe to tell us about the back-end tech stack.
For the back-end side of the project, we decided to use Amazon Web Services, or AWS. We chose AWS because its ability to integrate services that could be applied to our app. It's widely used in the industry, and we wanted to challenge ourselves with learning a new technology that was not covered in the course. We chose DynamoDB as our database as it uses key value pairs to sort data, making it more appropriate than other databases for the interaction between the user and the business itself. DynamoDB also provides us with the opportunity to scale our app, as well as learning a brand new database that is popular amongst developers. Identity access management was also used, as it provides security for the user and because they support roles via CRUD requests. Lambda functions along API gateway was also integrated as a requirement for requests to be passed to the DynamoDB database, returning a JSON object that we were familiar with. Finally, we used Node and Axios to mock API calls to apply test-driven development throughout the backend side of the project. Jack will now speak about the interaction between the user and the database itself.
Thank you, Joe. So how does all this work? Well, API Gateway is essentially the gatekeeper. It takes each user request, passes it onto a Lambda function which is tailor-made to deal with that request, and then Lambda processes the request, interacts with the database, and then sends the response back to the user. Now, a good analogy for this is like in a retailer like Argos, where you'll hand the cashier your slip, API Gateway, they'll see if they can process your request, a Lambda function, they'll check their stockroom, DynamoDB, and then they'll bring your item back, which is the response. So on each triggering of a Lambda function, the response gets logged in CloudWatch, which is really useful for in things like test-driven development, where you're wanting to see what is the actual response from your function. So with all that being said, we will now pass you on to Jodie and how we translated all of this into the front end.
Thanks, Jack. On the front end, we decided early on that we wanted login capability for our website so that businesses could directly update their business page when logged in. We debated using Firebase, but eventually settled on AWS Amplify and Cognito. Although the learning curve with AWS is steeper, we felt it was a valuable use of our time because we wanted to explore AWS services further and felt it would enable easier integration with the backend. As we were aiming to make a progressive web app, performance was a key factor in all of our tech decisions. We used Node and React to enable the quick build of reusable components. React also comes with built-in search engine optimization and faster rendering due to its virtual DOM. For the same reason, we used Reach Router to enable rapid navigation around the site without refreshing the entire page. To render the map, we used Leaflet, which is an open-source mapping software that works well on mobile phones. Finally, for the styling, we built on our CSS by integrating some components of Material UI. This facilitated more consistent styling across the front end and also gave us experience of using a UI framework. Now I'll pass back to Jack, who'll talk about some of the challenges we faced.
Thank you, Jodie. So the challenges that we faced in this project were actually great opportunities to learn. The first of which, we ran short of time when trying to implement all the aspects of our PWA. So we solved this by prioritising things that made our project clean and responsive and robust. The second of which, we were diving into new technologies, which we solved by digging into the documentation, knowledge sharing, and using trial and error. The third of which was remote working, which we kept our daily stand-ups by Zoom. We used Slack, we used Discord. There were many technologies that we used just to make sure that we was always in the loop with communication. And Joe will now talk about the future of our project.
Throughout the project, we tried to implement agile practices through twice-a-day stand-ups and Zoom or Discord calls. This ensured that everyone in the team knew the end goal of the project and prevented coding conflicts that could have otherwise occurred. These conflicts were also minimised using Git version control. For the future of this project, we'd aim to apply further user features, such as being able to book the number of tables the user wants and for this to be passed to the business accordingly. Additionally, due to the flexibility of our database, we'd aim to expand to other cities outside Leeds, along with adding further PWA features across all browsers and devices. Finally, we'd continue to add more error handling to the back end for a nicer user experience overall and aim to include more test-driven development. Thank you for listening. We hope you enjoyed our app demo and we're open to any questions you may have.
Hello, we are Aslina Yo, Haz Malian, Dan Smith, Charlie Holland, and me, Alan Turner, and I'm here to introduce our app, TapThatMap. TapThatMap is a multiplayer game based around Google Maps that we built because we wanted to build something fun that could also be somewhat educational, and our team wanted the challenge of building a real-time multiplayer game. As far as possible, we tried to build it so that it was simple to use, so that it could have a broad appeal. And to achieve this, we used daily stand-ups, test-driven development, and pairs programming for our work, starting by setting the MVP as the single-player version of the game. We managed to achieve this MVP in about 6 days, and from there, we really focused our effort on the multiplayer implementation. I'll now hand you over to Charlie for a demo.
Hi everyone, so let's play a round of TapThatMap. Upon logging in to TapThatMap, you'll see that you're asked to provide an email and password, either to log in if the email exists on our database, or to sign up if it doesn't. I've got a new email here, so I'm signing up and I'll be asked to enter a username and submit a custom marker if I don't like the duck we have. I've got a Northcoders logo here, so I think I'll use that today. And on pressing submit, I'll go to the front home page. TapThatMap can be played in single player or multiplayer, and multiplayer uses a game ID which you can use to join a lobby that's in progress. I'm setting one up here, so here's my game ID which I'll pass to my fellow teammates, and they'll come and join the game to show you that it can be played with multiple players. So we have Al here already, and Haz will be joining in just a second. Here we go, we have Dan here now, so as the host I have the option to start the game, which loads up our custom styled Google Maps API. Once everybody's pressed ready, I will have the option to start the game, again being the host, that will be my option, and we'll be able to play the game properly. Here we go. So question 1 is to find Gabon, which I'll admit I didn't know where it was. So I'll place my marker in the centre of Africa roughly, and then the program will tell me how far away I was from the centre. You'll see that other players, their scores are appearing on the right and their markers are appearing on the map, and they will drop in when they submit their scores. So if I submit my score first, I'll watch everybody drop in. If I submit my score at the end, I won't see anybody's markers until I've submitted, and then everybody's will appear on my map at once to obviously prevent them appearing and showing me where the answer is. So you'll see here with Haiti I got a little bit closer, and we see other people's markers dropping in, with Haz coming in at the end, they're nice and close as well. The rounds last for 60 seconds, but the timer will stop once everybody's confirmed their answer. And there are 10 rounds in total in the game. Once the question has been completed and your scores have been calculated, it'll ask you in the bottom if you're ready to move on to the next question. And again, when everyone has confirmed they're ready, the host will have the option to click next and move on to the next question, which resets the map as you can see here. So if we fast forward over to the final round, and we'll see that after question 10, the ready and next button will change to the results button, which will bring us, instead of to another question, to our final results page. The results page shows you as a player's score for each round, and then the entire lobby's scores ranked. So you can see here that Daniel has won by a considerable margin, which is something we found quite a lot during our testing. The option then is to go back home to obviously play another game, which I'm sure you'll all want to do. So I'll pass over to Aslina now, who's going to talk about the front-end systems.
Hello everyone, I'm now going to talk about the front-end technology we used in our web app. We as a team decided that the best way to reach anyone, anywhere and on any device is to code the game as a progressive web app, also known as PWA. A PWA is designed to be capable, reliable, and also installable, thus giving our user a native-like app feel to our game. This is even when our game is built using a single code base, in our case JavaScript. This suited our requirements and vision for our game perfectly. We chose React.js as a framework for building our game because its production build has all the tools necessary to generate a first-class progressive web app. Also, the Google Maps JavaScript API, which we used in our map, integrated seamlessly into React.js. As you can infer from the name of our game, TapThatMap, the Map API is the core component of our game. In order for our game to be aesthetically pleasing and also interactive at the same time, we required a robust but powerful Map API, which we found in Google Maps API. With Google Map, we are able to not only add, remove, and edit markers, but to animate them. With Google Map, we can manipulate latitudes and longitudes of points on the map. This is crucial in order to calculate scores in the game and also create boundaries for each country on the map. Last but not least, Google Map enables us to create customized map styles. This allows us to create a high contrast map style to cater for the visually impaired and also beautify the map according to our game theme. We used Material UI to create the user interface for our game. By using Material UI, we did not have to create custom components from scratch and could focus the bulk of our time on building our game engine and further it from a single player to a multiplayer game instead. The ability to provide a theme for our game with the use of Theme Provider is also a plus, as it helps us create visual consistency throughout the game. To sum it all, Materials UI gave our game a polished, responsive, and well-designed look. As with any other game, the use of sound and effects is integral to the building of a game. We used Howler.js as it is a simple and light API. This makes working with audio straightforward, and being only 7 kilobytes in size does not add bulk into our codebase. I will now pass the screen to Dan to talk about the choices we made in our back-end technology.
We went with Firebase as our back-end technology, as it is a real-time database which allows us to store and sync app data in milliseconds. Along with that, it was a new technology which was different to the relational Postgres database we had previously used. Firebase required a lot of work early on in order to get the basic understanding of reading and writing of databases and figuring out how to best format that data. We had a good understanding of Firebase and a functioning single-player game. We headed up to set up the multiplayer. Multiplayer required a host and client players. The host controls the game through making changes to the database, and the clients respond to those changes using listeners provided by Firebase. This allows us to sync up the rounds, thereby allowing players to play alongside one another in a more interactive game style. In the multiplayer, the marker and score data for individuals are sent to the database. Opponent players use that data to plot those markers and present those scores. This occurs in real time, so opponents' markers will pop up on the map as they are placed. We wanted players to upload image to be used as their markers. For this, we needed an easily accessible service in order to keep the game running smoothly. We went with Google Cloud Storage, as it is available from the Firebase account and allows clients to directly upload images to the cloud, and whenever that user starts a game, the correct images will be downloaded. We used Firebase authentication, which made implementing login functionality simpler and gave us access to the user data across the app. And finally, we hosted the database on Firebase and used Git Actions to auto-deploy the app when the master branch on the GitHub repository was updated.
Hi everyone, here are some of the challenges we faced whilst building TapThatMap. Firstly, we knew we needed a really comprehensive set of data to enable us to generate questions, plot country centroids and their borders on the map. We found a list of GeoJSONs online that provided all the information we needed and were quick to implement this. However, when we began playing the game, we started to notice a few inaccuracies. We kept logs of these and were able to update the data where it was needed, but I think the best example that shows one of the problems we faced is this picture of France's centroid being plotted in Spain. It took us a while to figure out, but it's actually because it takes into account overseas territories, and obviously France's central centroid is not quite in central France. One of the other challenges we faced is what I like to call customization frustration. Right at the start, we spiked out various map APIs to see which one would give us the best results for personalization. Google Maps API was the one that fitted our needs best and would enable us to make the game the way we wanted it to look. When it came to plotting custom markers on the map, we were initially a little bit surprised by the size of them, but luckily an extra set of parameters meant that we could limit this and that users were still able to upload custom images. So if we'd had a bit more time and we'd been able to do things a little bit differently at the start, I think we'd have liked to do things that would have increased the playability of the game. This includes things like different kinds of questions, maybe country flags or landmarks, things like being able to choose a theme to view the game in different colours, and allowing the user just a little bit more personalisation. At the moment, they don't have an option to change their user image once it's been uploaded, but we think that would have been a nice touch. Lastly, we feel the multiplayer game can get a little bit clunky, especially when you're waiting for every player to be ready. We think it would have been nice to implement a force start button on this, just so that the host could have complete control of when the round starts. Thanks everyone for watching, it's been an absolute blast and we're really proud of TapThatMap.
Thanks so much to all of you for joining us, and well done once again to our graduates. Please show your love, stay safe, and remember once more, though we may not embrace, our hearts are closer together than ever, all right?